Filters in ASP.NET Core are a powerful feature that allows you to run custom logic before or after specific stages of request processing. They are particularly useful for addressing cross-cutting concerns such as logging, caching, exception handling, validation, or modifying responses. Purpose of filters. Filters serve to intercept the execution pipeline of ASP.NET Core applications. They provide hooks to inject behavior before or after an action method runs, action filters. Results are processed, result filters. Authorization checks occur, authorization filters. Exceptions are thrown, exception filters. Filters help maintain a separation of concerns by centralizing logic that would otherwise be repeated in multiple controllers or action methods. Types of filters and their use cases. 1. Authorization filters. Purpose: enforce authorization logic before other filters execute. Use case: to check whether a user is authenticated or has specific roles/permissions. Example: authorize attribute. 2. Resource filters. Purpose: run before model binding and after authorization. They can short-circuit the request pipeline. Use case: implementing request caching or pre-processing heavy resource checks. Example: setting up request culture settings. 3. Action filters. Purpose: execute custom logic before and after an action method runs. Use case: logging, request/response validation, or modifying input/output data. Example: adding a header to responses or validating action parameters. 4. Exception filters. Purpose: handle exceptions thrown by controllers or action methods. Use case: implement centralized error handling logic or return user-friendly error messages. Example: logging and returning a standardized error response format. 5. Result filters. Purpose: run before and after the action result is executed. Use case: modifying or enriching the result, such as adding custom headers to HTTP responses. Example: transforming data for a specific client format. How filters work in ASP.NET Core. Filters are executed in the order they are defined in the pipeline. Before stage: pre-action logic, e.g., validation logging. Action execution: the actual controller action method runs. After stage: post-action logic, e.g., formatting the result, performance monitoring. If a filter short-circuits the pipeline, e.g., by providing its own result, subsequent stages may not execute. Implementing a custom filter. Create a custom filter. To create a custom filter, you implement one of the filter interfaces or extend a filter base class. Example: custom logging action filter. This filter logs the start and end of an action method and measures its execution time. The provided code defines a custom action filter in an ASP.NET Core application named Logging Action Filter that implements the iActionFilter interface. On action executing, this method is executed before the action method starts. It starts a stopwatch to measure the execution time and logs that the action is starting. On action executed, this method is executed after the action method has completed. It stops the stopwatch and logs the time taken for the action to execute. Purpose: to log the name of the action being executed and the time taken for the action to run, providing useful information for debugging and performance monitoring. Register the filter. You can apply your custom filter in several ways. Globally, applies to all controllers/actions. Shown code is part of the configure services method in the startup class of an ASP.NET Core application, used for configuring services that are available to the application. Services to add controllers. Options equals. This line adds the controllers to the DI, dependency injection, container, and configures options for MVC controllers. The options parameter allows you to customize controller-related behaviors, such as adding filters or modifying routing. Options, filters, add, logging action filter. This adds the logging action filter to the global filters for all controllers. As a result, the logging action filter will be applied to every action method in the application, automatically logging the start and end of each action method along with the execution time. to register the logging action filter globally so that it is applied to every controller action in the application, enabling logging of execution times and other details automatically for all actions. At the controller level, in this code, logging action filter, this attribute is applied to the home controller class, meaning the logging action filter will be executed for every action in this controller, in this case, the index action. Home controller. This is a standard ASP.NET Core MVC controller that inherits from controller. It handles HTTP requests and returns views or other types of responses. Index. This is an action method in the home controller. It returns a view when accessed. Purpose. The logging action filter will log the execution time and details whenever any action, like index, in the home controller is executed. Test and verify. Run the application and access the controller/action where the filter is applied. You should see the log output in the console indicating when the action started and finished, along with the execution time. Filter execution order. Filters execute in the following order. Before the action, authorization filters, resource filters, action filters. The action method executes. After the action filters, result filters. If exceptions occur, exception filters are invoked. Advantages of using filters. Code reusability. Centralized logic avoids repetitive code. Separation of concerns. Filters keep controller actions focused on core functionality. Modularity. Filters can be applied only where needed. Cross-cutting concern management. Ideal for logging, caching, and security concerns. Conclusion. Filters in ASP.NET Core are a robust mechanism for adding pre- and post-processing logic in a clean, reusable manner. By implementing custom filters, developers can address common needs like logging, exception handling, and validation while keeping the codebase maintainable and efficient.